Hey guys, today we're going to do something cool. We're going to crop an image. Oh yeah. So let me open up JES and let's get started real quickly. Awesome. Save this file as just, crop py. And what we're going to do is we're going to make a function. We're going to call it crop. So we want to crop a picture. But when you crop a picture, you need to define where you want to crop it. So you want to crop it from one point, which is going to be x1, y1, and to another point, which is x2, y2. And note that x1 must always be less than x2, and y1 must always be less than y2, or else we won't be able to grab the pixels that we want and an error will be raised because we're like inverse cropping. Anyways, I just had to mention that. Now what we're going to do is we're going to find the difference in x and the difference in y. So I'm just going to call this capital X, capital Y. Now the difference in x is the difference like that. Even I don't have to put these absolute value signs because we stated that x1 is less than x2 and so on. Oh yeah, actually I do. Never mind. I forget what I said. Okay, so we're going to make a new image. I'm going to call it cropped image. And we are going to set that equal to make empty picture of boundaries xy. And the size of the image is xy because that's the region we want to crop. Okay, cool. Now, when cropping an image and pasting it on another canvas, what is interesting is we're not working in the same coordinates, if you want. One is more shifted than the other. Therefore, it's easier sometimes just to take all the pixels in the region of the original image and just paste all of those into the cropped image, our new image. And that's what I'm going to do. Or else you're worrying about XY positions all the time, and to be honest, it's just more confusing. So I'm going to define a function called grab pixels, and it's going to take an image P, next one position, Y1 position, X2, and Y2. And we're going to define a new list called pixels. And pixels is going to store all the images in P within this range. So for X, the range of x1 to x2, and for y in the range of y1 to y2. And what we're going to do is we're going to grab the pixels within these boundaries and shove them in pixels. So to do that, just do pixels.append, and now we're going to snag a pixel object at x, y. Awesome. And finally, return pixels. So that's how you grab all the pixels within certain coordinates of an image, and then we're returning that. So let's get our original image pixels. It's going to equal to grab pixels of picture at x1, y1, x2, y2. Just so you guys can see like that. And same thing, cropped image. So crop, that was 4 P's. Cropped image pixels equal grab pixels and cropped image at, again, actually, the pixels we're going to grab in the cropped image are going to be slightly different because they're going to be starting at 0, at 0.00, and ending at x, the difference in x and the difference in y. Now this should make sense to you because this is a new canvas. And these coordinates are probably out of bounds or will be out of bounds unless they're exactly the same size, which wouldn't be a crop. So we're just going to get the difference in x and y. Awesome. So next, what we mean to do is we're going to loop through both of these lists at the same time and set the color of the original pixels to the color of the cropped pixels. So for pixel set and zip, and zip is a function that merges these two lists. Since they're going to be the same size, that's a key component of using zip. If they're not the same size, do not use zip. Do not. It will like screw everything up. It'll like cut a part of your list to match the smallest list, and you don't want that ever. Well, you might sometimes, but not in our case because we'd be losing information. So original image pixels, cropped image pixels, like that, put a colon there, and let's call it pixel original is going to be equal to pixel set 0. And that's because it's the first of, like, this contains two things. It'll contain one pixel from original image and another pixel from cropped image. And I'm just getting the first one. I'm setting the original pixel equal to the first one of the pixel set because original pixels came before crop pixels in the zip. If it was the other way around, then I'd set this equal to 1. Yeah. So the cropped pixel set at 1. And now all we need to do is transfer the color over. So set the color of our cropped, why did I call it pixel cropped pixel? There we go. Of our cropped pixel, get color of our pixel original. And we want to return the cropped image, and we are done. Okay, let's see if this works. So let us load an image. Just call it age equals make empty. No, not make empty picture. Just make picture. Pick a file. Now let's go grab one. Pixels, fun images. This one. And this is the picture of the purple planet. Now we only want a certain portion of the purple planet, so let's crop it. Crop, like that. Crop age at, say, 100 to coordinates, I don't know, 300, 500. Let's run this thing and see what we get. Let me show you guys what C looks like. and indeed we just get a certain strip of H, and that's exactly what we wanted. So let's go back down here and see what I did. I made a function called grab pixels, which would essentially just grab pixels within a certain boundary and put them in a list called pixels and return that list. Over here we got the x and y difference. So down here when I entered 100 and 300, the x difference is 200 and the y difference would be 400. Okay, now we make a new cropped image with those dimensions. We get all of the cropped and original image pixels at their respective areas. Then we loop through both the original and the cropped pixel, and we set the color of the cropped pixel to the color of the original pixel, and we return that image. And that's as simple as it gets. So guys, thank you very much for watching. Hope you learned something, and catch you later.